we need to solve this equation. The logarithm base 3 of x plus 1 plus logarithm base 3 of x plus 3 equals 1. Before solving this equation, we define the range of possible values. Expressions under the logarithm should be greater than 0. X plus 1 is greater than 0. And the second expression, x plus 3, is greater than 0. Thus, we have obtained a system of inequalities. Solving the system of inequalities, we obtain the following. X is greater than minus 1. And x is greater than minus 3. Let's draw the coordinate axis. Here we have minus 1. And here minus 3. According to our system of inequalities, the value of x should be greater than minus 1. According to the second inequality, the value of x should be greater than minus 3. As you can see from the figure, the solution of the system is x is greater than minus 1. So, we found the range of possible values. Now, let's look at our equation again. As we can see, the base of both logarithm is the same, and it is equal to 3. Therefore, we can use the well-known formula. The logarithm base k of a plus the logarithm base k of b equals the logarithm base k of a multiplied by b. That is, the sum of the logarithms with the same base equals to the logarithm of the product. Then our equation takes the following form. The base 3 logarithm of x plus 1 multiplied by x plus 3 equals 1. To solve this equation, we need to recall what a logarithmic function is. Logarithm base k of a is equal to b. Then the inverse function will look like this. A is equal to k to the degree of b. In other words, both of these equalities are equivalent to each other, provided that the value of a is greater than 0. Consequently, we can write down our equation in the following form. X plus 1 multiplied by x plus 3 equals 3 in the first degree. We solve equation in the bracket. Then we get x squared plus 4x plus 3 equals 3. Or x squared plus 4x equals 0. We take the common factor x. X multiplied by x plus 4 equals 0. The product of two factors is equal to 0 if one of the factors is 0. In other words, we have obtained two equations. X is equal to 0. And the second equation, x plus 4 is equal to 0. So, one root of the equation, x is 0. From the second equation, we find the second root. So, the first root is x1 is equal to 0. And the second root of the equation, x2, is equal to minus 4. All we need is to verify if our root values are in range of possible values. As we remember, the values of x should be greater than minus 1. Consequently, x equal to minus 4 cannot be the root of our equation. Thus, our equation has a single answer. X is equal to 0. Good luck! Solve problems with the support of the Bank of Astana.